Hello again. Now in this tutorial, I'm going to tell you how you can delete the last node of the linked list. In the last tutorial, we saw how we can delete the first node, and that was straightforward. We updated only the head pointer there, and we assigned the address of the second node there into the head pointer so that the head could point to the second node, and we deleted the first node. But here, in order to delete the last node that's there at address 4000, we need to update the tail pointer this time. Now you can see that the tail is pointing to the last node, and if we are going to delete this current last node, we need to assign this 3000, that's the address of the second last node, to tail so that the tail could point to the last node, and then we need to update this next pointer field of this node to null. Okay, so now the problem is that how could we find the address of the second last node? That we can do just by running this loop. We'll be taking a pointer there. That means we need to iterate through the linked list. We need to traverse the total linked list in order to get the address of the second last node. Now the node that contains address of the last node in its next field is the second last node. You can see that it contains 4000, and that's the address of the last node, right? So the node that contains the address of the last node, current last node, in its next pointer field, that's the second last node, and that we need to search. So it's going to be a linear search. So we'll use a pointer, current, a node pointer. We'll pick up the address of the first node from head. So 1000 will be assigned to this current, and we will move and iterate using this while loop. You see that current, oh, it should be current arrow next. Okay, it should not be current arrow next. That's the thing. Current arrow next is 2000, and that is not equals the content of tail, that is not equals 4000, right? So what we'll be doing, we'll be moving to the next node, current equals current arrow next. So now the current arrow next is 2000, that is assigned to current. So the content of current is 2000, so current will no longer be pointing to the first node, it will come here. Now again, we'll be iterating back here in the while. Current arrow next is 3000. You can see that it's 3000 right now because the current is pointing to this 2000. This is the node that is the address of which is right now in the current. So current arrow next is 3000, not equals tail, not equals 4000, correct? Now the content of the next is assigned to current again. So this 3000 is assigned to current. So current gets 3000, and current will no longer be pointing to this second node, it will be pointing to the third node now. Now we'll be iterating back here. Now you can see that current not arrow next not equals tail, that is false right now because the current arrow next right now is 4000. It is pointing to the next node, right? So now the while loop will terminate, and we are out of this while loop. Now you see that after this while loop, the current pointer is right now pointing to the second last node. Now you can just update the tail with the content of current. So we'll be just doing this operation, tail equals current, and that will update the tail. So the tail will be pointing to this, and then we'll be just assigning null to this next pointer field, and it will free this node. Okay, that's it. That is how we are going to write the program for deleting the last node of the linked list. But there is a difference between delete first and delete last, and that you need to understand clearly. In case of delete last, we have that loop that's going to traverse the entire linked list to get the address of the second last node. Now, if the number of nodes are huge, then obviously the performance of the delete last is going to be poor. But in case of delete first, we do not have any such loop, and it doesn't depend on the number of nodes there. So if you are doing the delete first operation, it's independent to the number of nodes of the linked list because you do not need to traverse the linked list, right? So whatever be the number of nodes in the linked list, delete first is going to take always the same amount of time. But in case of delete last, if the number of nodes increases, it will take more time to get the address of the second last node, as we see while doing that logic. So as far as the performance is concerned, obviously the delete last is poor. Now, in order to do away with this, we have an alternative there, and that's the doubly linked list. In case of doubly linked list, we'll see that each node contains the address of the immediate next node as well as the immediate previous node. So in order to get the address of the second last node, in case of doubly linked list, we can get that from the last node because the last node contains the address of the immediate previous node as well. So we'll see that how we can do that in case of doubly linked list. But as far as this singly linked list is concerned, this delete last operation is obviously dependent on the number of nodes there in the linked list. So let's now go ahead and write that function delete last. Okay, so here you go. If the linked list is empty, the handling remains same, just as we did in case of delete first operation. Now, if there is only one node, this case is also the same as we did in the delete first operation. We are just assigning null to head and tail because we are deleting the only node that we have in the linked list. Otherwise, if there are many nodes, then as I said earlier, we need to traverse through the linked list and get the address of the second last node. So for that, we need a pointer. So let me declare one there. So node pointer current. And we are assigning the address of the first node there to this current pointer, so that the current is right now pointing to the first node. Okay, now we need another pointer there in order to access the last node. So I'm declaring that as last node pointer, as you can see there. So lstptr arrow tail. So we're picking up the address of the last node from tail and assigning that to the last node pointer. So the last node pointer is right now pointing to the last node. So let me just get the data from that last node there so that we can return it to the caller later on after deleting the node. So now in the else part, we need to iterate through the linked list. So I'm writing that while loop, current arrow next, not equals lstptr arrow tail. As long as we do not get the address of the last node in the next pointer field, we need to move ahead and go to the next node. So current equals current arrow next. So we are actually searching for the address of the last node in the next pointer field of each node starting from the first node. So when we come out of this while loop, obviously the current is pointing to the second last node and we need to assign that to the tail pointer. So let me just update the tail pointer now, lstptr arrow tail, and that is going to be assigned with, that we need to assign with current. So now the tail pointer is pointing to the second last node, and we need to obviously update the next pointer field of this second last node as well, that is to be assigned with null. So lstptr arrow tail arrow next, it should be null, as this node is going to become the last node. So we are done with that, and after coming out of this else, what we need is to free that last node. Okay, so last is the pointer that is pointing to the node that we are going to delete. So we're just freeing that using the free function, so it will be deallocated. So now we just need to decrement the node counter, lstptr arrow node count. That should be decremented by 1. Finally, we need to just return that data to the caller. And that's it. So let me just go ahead and compile this. I'll add this in the switch case. I think I did that. Here you can see that we have updated that case 9, delete last. Okay, so gcc linked list.c. We have some error there. Expected semicolon, that's silly, right? I have a mistake there. I have written WHLE and not while. Okay, let me just update that. Okay, here we go. That was silly. So it has been compiled now successfully. So let me just go ahead and run that. I'll load the data from the file and create the linked list. Option 1 has been done. Option 6, printing the linked list there. So here it is. Now I'll just call the option 9 to delete the last node. The last node contains 123. You can see that. So here we go. We get 123 there. And if I display the linked list, we'll not get that 123 there. Now if I just invoke the delete last once more, it's going to delete the node that contains 42. 42 is the content of the last node right now. So you get that there, 42. Now if I can display that, see that 42, the node contained that 42 has been deleted. Okay, so we are done with this delete last. Now in the next tutorial, I'm going to do the other delete operation, that's going to be the delete a target node, right? That means we'll be searching the nodes there in the linked list for a particular target value. If that exists in a node, we'll be deleting that particular node that contains the target value. So in the next tutorial, we'll see how we can do that. Thank you very much.